Download this code from codegive.com, link in the description below. Certainly. In .NET development, particularly when using LINQ, language integrated query, it's common to work with IEnumerable. However, improper usage can lead to performance issues, especially when dealing with large collections or when the code is executed frequently. The rule "Stop using IEnumerable the wrong way" from codecop 019 highlights some common pitfalls and suggests best practices. Understanding IEnumerable. IEnumerable is a generic interface that represents a collection of objects that can be enumerated. While it's a powerful feature in .NET, using it recklessly can lead to performance degradation due to deferred execution, multiple enumerations, and unnecessary allocations. Common pitfalls. 1. Multiple enumerations. When you enumerate an IEnumerable multiple times, it can lead to performance issues, especially if the underlying collection performs a lot of computations or accesses a remote data source. 2. Deferred execution. LINQ queries are not executed until you iterate over them. This can cause unexpected behavior if the underlying collection changes before the execution occurs. 3. Inefficient LINQ queries. Certain LINQ operations can be inefficient if not used properly, such as using count, or toList, on a potentially large dataset. Best practices. 1. Materialize collections. If you need to enumerate the same collection multiple times, consider converting it to a list or array using toList, or toArray. This way, you avoid redundant computations. 2. Use forEach. Prefer using forEach for simple iterations instead of LINQ when you don't need the additional features of LINQ. 3. Avoid unnecessary operations. Be cautious with operations like count, any, and others that can lead to multiple enumerations. Example of wrong usage. Here's an example of improper usage of IEnumerable. Sharp. Public IEnumerable int getNumbers. / simulating a data source that generates numbers. 4. Int I equals 0, I10, I++. Yield return I, / using yield returns an IEnumerable. Public void process numbers. Var numbers equals getNumbers. / multiple enumerations. This can be inefficient. Console.read count, plus numbers.count, / first enumeration. For each, var number in numbers, / second enumeration. Console.read number. In this example, getNumbers uses yield return, which means numbers will be enumerated twice, once for counting and once for printing. This could lead to performance issues, particularly if the data source is more complex. Correct usage. Here's how to fix the above code. Sharp. Public IEnumerable int getNumbers. 4. Int I equals 0, I10, I++. Yield return I. Public void process numbers. / materializing the collection to avoid multiple enumerations. Var numbers equals getNumbers, dot toList, / convert to list to avoid multiple enumerations. Console.read count, plus numbers.count, / only one enumeration now. For each, var number in numbers. Console.read number. Summary. Avoid multiple enumerations of IEnumerable. Materialize collections when necessary. Be aware of deferred execution with LINQ. Use forEach for simple iterations instead of LINQ when performance is a concern. By following these best practices, you can enhance the performance and reliability of your .NET code. Certainly. The Stop Using IEnumerable the Wrong Way warning in .NET Code Analysis, specifically Code Analysis Rule CA0191, encourages developers to avoid using IEnumerable inappropriately, which can lead to performance issues and unintended behaviors. Understanding IEnumerable. IEnumerable is an interface in the .NET framework that represents a collection of objects that can be enumerated. While it's a powerful feature for working with collections, using it incorrectly can lead to inefficiencies, especially in scenarios where deferred execution is involved. Common issues with IEnumerable. 1. Deferred execution. When you use LINQ methods on IEnumerable, they often return a new IEnumerable that executes the query only when you iterate over it. This can lead to performance problems if you're not careful. 2. Multiple enumerations. If you enumerate an IEnumerable multiple times, it can lead to unexpected results or performance hits, as the underlying collection may be re-evaluated each time. 3. Inefficient queries. Using IEnumerable with methods that don't optimize the data retrieval can lead to suboptimal performance. Code example. Let's consider a scenario where these issues could arise, and then we'll look at how to resolve them. Problematic code. Here's an example of code that demonstrates these issues. Sharp. Using system. Using system.collections.generic. Using system.LINQ. Public class program. Public static void main. IEnumerable int numbers equals get numbers. / This could lead to multiple enumerations if used incorrectly. Var even numbers equals numbers.where, n equals n%2 equals 0. / enumerating multiple times. Console.read even numbers. For each, var number in even numbers. Console.read number. Console.read count of even numbers. Console.read even numbers.count. Private static IEnumerable int get numbers. 4. Int I equals 0, I10, I++. Yield return I, / deferred execution. Issues in the example. 1. Deferred execution. The get numbers method uses yield return, which creates an iterator. This means that every time even numbers is enumerated, it re-evaluates the get numbers method. 2. Multiple enumerations. The even numbers enumerable is being counted after it has been enumerated once. This can lead to performance issues since get numbers will be executed again. Recommended fix. To avoid these issues, you can materialize the results of your IEnumerable into a concrete collection, such as a list T, which will evaluate the query and store the results for future use. Fixed code. Here's a corrected version. Sharp. Using system. Using system.collections.generic. Using system.LINQ. Public class program. Public static void main. / materializing the query into a list. List int numbers equals get numbers, to list. / now we can safely enumerate without worrying about deferred execution. Var even numbers equals numbers.where, n equals n%2 equals 0, to list. Console.read even numbers. For each, var number in even numbers. Console.read number. Console.read count of even numbers. Console.read even numbers.count. Private static IEnumerable int get numbers. 4. Int I equals 0, I10, I++. Yield return I, / still deferred execution, but we will materialize it. Key takeaways. 1. Materialize collections, use .toList, or .toArray, to materialize the results of an IEnumerable when you plan to enumerate it multiple times. 2. Be aware of deferred execution. Understand how deferred execution works with LINQ and IEnumerable to avoid unintended performance issues. 3. Use appropriate collections. When you need to perform multiple operations on a collection, consider using concrete types like list or array. By following these best practices, you can avoid the pitfalls associated with using IEnumerable inappropriately in your .NET code.